Have you ever found yourself just wrestling with for loops trying to process collections in Java? You know, it can get pretty messy. Well, you are in for a treat today. We're going to look at Java streams, which is basically like building a data assembly line. It's the super powerful, modern, and honestly incredibly clean way to work with your data. It's going to make your code so much more readable. Okay, let's dive in. So, take a look at this. On the left, you've got the old way, the classic for loop. It's a bit clunky, right? It takes up several lines, and it kind of mixes up what you're trying to do with how you're doing it. But then, look at the right. That's the stream way. It's this single, elegant chain of operations that almost reads like a sentence. It tells you exactly what's happening step by step. The difference is just night and day.
So the big question is, how do we get there? How do we go from that tangled-up loop to this clean, efficient pipeline? How do we actually build this assembly line piece by piece? Well, that's exactly what we're going to break down right now. Here is our plan, our blueprint for the factory floor. We'll start by setting up the main assembly line. Then we're going to visit 3 key stations: quality control, the transformer, and the final product station. And at the end, we'll even look at some cool line upgrades and then wrap it all up. All right, let's get to our first stop on the line, Station 1, quality control. This is where we bring in the dot filter method, and it's all about deciding which data even gets to come inside. I want you to think of the filter method as a really strict gatekeeper. As each piece of data, each item, comes down the conveyor belt, the filter inspects it. It checks it against a specific rule. If it passes the test, great, it continues on. If it fails, it gets tossed aside. It's that simple. So how does our gatekeeper know what to do? It follows a rulebook, and in Java, this rulebook is called a predicate. Now, don't let the fancy name fool you. A predicate is a super simple thing. It's a special kind of interface that has just one job: to run a test on an item and return true or false. True means you can pass, and false means, nope, you're out. Now, before we jump to the shiny new syntax, it's really helpful to see what's happening under the hood. This here is the long way of writing that rule. We're creating a full anonymous class. We have to manually implement that test method, which takes a number, checks if it's even, and returns true or false. This is what Java's actually doing in the background. And check this out. This is the magic of the upgrade. Because that predicate is what we call a functional interface, meaning it only has that one single method, we can get rid of all that boilerplate code and just replace it with this clean, simple Lambda expression. That's it. It does the exact same thing as all the code on the last slide, but in one beautiful, readable line. All right, so our data has passed quality control. Only the good stuff is getting through. Let's move on to the next station on our assembly line, Station 2, the transformer. This is where we use the .map method. The map station is where things get really interesting. It takes every single item that the filter let through, and it transforms it. It doesn't just look at it, it actively changes it into something new based on a rule we give it. So for our example, let's say we want to take every number that comes through and double its value. And you guessed it, just like our filter station, the map station has its own rulebook. This one's called a function. A function also has just one method, this time called apply. Its job is to take an item, apply some logic to it, and then return a new transformed item. And again, let's peek behind the curtain at the long way first. You can see we're creating another anonymous class, this time for our function. Inside, we implement that apply method. It takes our integer n and, just like our rule says, it returns n multiplied by 2. You're starting to see the pattern here, aren't you? And boom, we upgrade to a Lambda. All that code from before just melts away and becomes this, n multiplied by 2. It's short, it's clear, and it tells the map method exactly what it needs to do. This is what modern Java is all about. Okay, so we've filtered our data, we've transformed it. Now it's time for the final step in our assembly line. We've reached Station 3, where we create the final product using the .reduce method. The reduce operation is what's called a terminal operation. That means it's the end of the line. Its job is to take every single item that has made it this far, all those even numbers that we doubled, and combine them all into one single final value. A really common example is just summing them all up. So how does reduce actually work? It's pretty clever. It doesn't just add everything up at once. Let's walk through it. First, it starts with an initial value. Let's call it the carry, and we'll set it to 0. Then, it grabs the first item from our stream and does the math. The result becomes the new carry. Then it just repeats this process,
carrying that running total forward until every single item has been processed. So the key thing to get here is that the Lambda for reduce takes two things: the carry, which is our running total from the last step, and the current element from the stream. Our little operation, carry plus element, gets performed, and that result becomes the next carry. It's just a really elegant way to build up a final result.
We've built our 3 main stations. Now let's do a quick recap and look at a few optional upgrades you can bolt onto your data assembly line to make it even more powerful. You can easily add more stations to your line. For example, you can drop in a .sorted method to sort your data right in the middle of the stream. Super useful for things like leaderboards. Or if you have a massive data set, you might use .parallelStream to split the work across multiple cores on your computer to speed things up. But just a word of caution, operations like sorted, which need to see all the data at once, don't always work well with parallel streams, so you have to use that one wisely.
And here it is, our complete assembly line in all its glory. We start with a source list of numbers. We filter for the even ones. We map by doubling each one. And finally, we reduce them all down to a single sum. It's just a clear, logical, and really powerful flow. And here's a quick little cheat sheet to help all this stick. Our quality control station uses .filter, and its rulebook is a predicate. The transformation station uses .map, and its rulebook is a function. And the final product is made by .reduce, which uses something called a binary operator. That's just the official name for our logic that takes 2 inputs and returns 1 output.
So at the end of the day, this is the big idea. We've moved away from these manual, sometimes error-prone loops, and we've built a declarative pipeline that clearly says what we want to do. It's so much more than just writing less code. It's a better way to think about processing data. So we've basically just given you the keys to the factory. You're the manager now, you understand the stations, you know the rulebooks, and you know how to connect them all together. So the only question left is, what kind of powerful, elegant data assembly lines are you going to create?